Hello guys, welcome to CS50 Problem Set 4 Lab 4 Walkthrough Tutorial and Solutions. Today we're going to talk about Lab 4 programs, distribution codes, overview, understand wave, and a detailed versions of overview, pseudocodes, headers, samples, and please pause the video before we move into the solutions. So for these Lab 4 programs, basically we type /volume inputs .wave output.wave 2.0. We will create another file called output.wave, and this output.wave, the volume is 2 times higher than the input. You can see 2 times is because we key in 2.0 here, as if we key in 0.5, the output.wave file is 0.5 times lower than the input .wave. It's basically like a multiplications with the original input wave file. So let's take a look in the distribution code. So we can see here there's a two new library here, standard ins.h and standard library. So standard ins, we have a few more functions to use, a specifier. So we can see here there's a 8t and 16t. So 8 means bits. So 1 byte, 8 bit is equals to 1 byte. So there's a signed and unsigned. That's why you can notice there's the U here means unsigned. So the difference between the signed and the unsigned is basically the signed has the space for negative and positive, while as the unsigned is only have the positive. So you can see here the positive value has more space than the signed value. Basically, it's just divide by 2. So as for the 16 is the sign here is also the same concept as the above. So from here we will focus on this at these two U in 8t and in 16t. So as for the standard library here, it consists of atof and malloc. So atof is basically convert the strings to floating-point numbers, and malloc is basically allocate memory from the heaps. So you can see here there's a constant integer header size 44, which is a global variable here. It meant it argc and char argv. So from here, this we are going to check for the command line arguments. So if argc is not equals to 4, it will print this statement. Basically, it means that when we key in this command line, so you can see here argc4. So this is arg1, argc1, argc2, argc3, argc4. So we should have one argc4 here, or if less than 4 or more than 4, it will prop this statement here. So you can see next we'll go to, we will open the file. Basically we just decline dot input pointers and open the file. So up v1. So up v1 is basically here the input.wave. So I just put it here. So you can see here there's a R here. R is actually means from read from. So the simplest explanation is just to open a file from the input.wave. If unable to open, it will just print could not open the file. So same goes to the outputs with file decline dot outputs pointers. So just open the up v2, which is the output dot wave, and we write from it. You can notice that we opens the input for write, for reads, and the output is for write. So both are slightly different. So if unable to open the outputs, so we just print these statements. So next we'll declines float factors, a variable factors here. So atois up v3. So up v3 is, you can see here, up v3 is the 2.0. So why we need this to convert to a floating point number? Basically from here is a string. So up v3 is a string. So we need this to convert to a floating point number here. So these two is where we're gonna do this. Then at last we're gonna f close the input and the output. So this is the overview. So we have the input.wave volume 50, for example. So we have the program. Then basically we need to key in a command line. So from here it will just create another file here. You can see here this is 2.0. So the volume times 2. Basically, it just copies some of the data here and rewrite it to create a new file wave, output.wave. So to copy a wave file, we need to understand what is within the wave. Wave is basically of audio file format. Is used for storing an audio bit streams on PC, developed by IBM and Microsoft. So consists of two chunks, the headers 44 bits and samples 2 byte each. So we can see here there's two portions, the headers and the samples. So FMT chunks specifies the data formats such as the size of file, number of samples per second, and size of each samples. Each of the data can be treated as a single bytes or 8 bits. So as for the samples is a data chunks which contains the actual sample size. So it's also a sequence of samples representing the audio signals at a particular point in time. So each samples as 2 bytes, 16 bits. So we can actually change the samples here just to multiply the samples by numbers, which is the factors in our case. So as for the overview, after we understand the wave, so for this process, we have two tiny steps. The copy 144 bytes headers by unsigned 8 bits and copy many 2 byte samples by signed 16 bytes and multiply samples with factors. So the factors is here. For our pseudocodes, so after the distribution codes, so we're going to copy the headers from input file to outputs. First, we're going to decline the headers arrays of 44 bytes. So we're going to read 44 bytes from input.wave and write 44 bytes from output.wave. So next, we're going to read the samples from inputs and write outdated data to the output files. So first, we're going to decline the buffer of 2 bytes. Then we're going to create a loop between the 3 to 5, read 2 bytes from the inputs, multiply the 2 byte with a factors, and write a new 2 byte samples to output.wave. So as for the copy headers here, so we can take a look in the examples of the CS50. So the type def is basically just to rename the air bits to bytes. So it's the similar as our distribution codes. Check for the axis opens with the file. Then we're gonna focus here. So this program is designed to read the first 3 bytes. So we rename it to bytes. So we decline an array of 3, the size 3. So fread. So we put, this is there's a format here. So you can see the file is actually the file from here, and the bytes is here, the size of bytes and 3. So what does all this means? can take a look and the documentations. So basically f reads here, there's a pointer, the sign, and the NMEMB and the dot star stream. So PTR is actually the pointers, the address of the first byte of memory which to read the data, and the size on in bytes on of the data to read. So you can see here size of bytes is actually 8 bits here. So NMEMB, which is the number of those type to read at once. So we're gonna read 3 bytes at once. So next is the streams, which is the pointers at the file returned by opens. So this is the file here. So for example, if reading one char at a time, the size will be a chunk. Char, then for our case is a byte at one at a time. So this will be 1. Ours we're gonna be 3 because we're gonna read 3 at once. So to have a more simpler way to understand here, so basically we just go to the file, then to the address. We're gonna read 1 byte at a time, then we're gonna read 3 bytes at once. So there's a file here. We're gonna read 3 bytes. We create this, we decline this here, a byte or size of 3. So from here, we're gonna take 1 byte at a time. Then we're gonna take this and go to where we want to locate. This is how we read 3 bytes at once. So this is hope you guys understand here. So next, as for our case here, we're gonna read the first 44 bytes from the input. Then we go through the headers, which is similar as the byte here. So we have 44 here, and one of them is represent of unsigned 8-bit at one time. So let's take a look on the right. Basically the right is similar. We just take all the size of bits, 3 at a time, with the location, just transfer to the output. So for reads inputs to here, for writes from here to the output. So for our lab 4, this will be the code here. So you unsign its 8t, which is the 8 bits. So we just decline an array of size n. The n will be around 44 here. So we also can use the global variable. And we have create the f reads because we want to copy the headers. So we're gonna put the address here, the size of the 8 bits here. So the n will be the 44 here, and from the inputs. So basically for writes is similar same. So for the headers here, the size of the 8 bits here. So the n will be the 44s, and here will be the output. So the red color is for you to fill it up. So let's move to the copy samples. So we use another example in the CS50 as an exercise. Same here, we're gonna rename here to bytes. Check for the argc3. So from this, is very close to our example. There's a read and a write. So we have a source and the destinations. So because we want to read and write is like the copy and paste, we need a row and the other folders to paste it. So from here, we can see here, there's a buffer here. Then there's a loop here, the while loop. So basically he read first and to rewrite it here. So I create a graphical graphical diagram here to explain. So we have a source here, but the source we do not know the total byte to read or write. We just know there's a lot of byte here. So we just want to transfer to the destinations. What we do here, we just create a variable here, which is for this case is 8-bit here. You can see the capacity is 8 bits. The inner box here, there's also got one 8-bit. So under a loop here, so we read the file from the source to the buffer, 1 byte at a time, read 1 byte at once. Then we'll go from the buffer to the destinations, write 1 byte at a time, write 1 byte at once. Then you can see here, there's a buffer, size of byte, 1, and the source. So this is a buffer, size of byte, 1, and destinations. So you just come back here. So for our case here is quite similar. Basically, we just change from the 8 to 16 bit, 16 bits, and 2 to just 2, 2. So same, we didn't know the total byte to read and write. So first, we're gonna create also a loop here. So just transfer here to read the source and just transfer here. But for this time, we're gonna change the data here. We're gonna multiply with the factors. So the idea here is basically just read the data here. So just read, for example, this line here. After we read, we got this buffer, we have a data. So this buffer, we have a data. Basically, we just do this. The buffer equals the buffer times factors. So we just slightly modified the samples here and just pass to the destinations. So here, it'll be slightly different data from our problem here, lab 4. So the idea is just to times the factors in this process here before it goes to the right. So from here, you can see here, this is for the lab 4. Just decline a buffer variable with 16 bits. Then we create a while loop similar as this. So every the buffer size of 16 bits, 1 at a time, and from the inputs, then we're gonna update the volume. So basically it's just like that. Just update the buffer after multiply with the factors. Then we write to the outputs. The buffer size of the 16 bits, basically just something like that. And 1 at a time, and to the outputs. So the red color is for you to fill it up. So that's it. Now pause the video and try solving it before continues to the solution sections. Welcome back. So we will go into the solution explanation sections. So you can see this is my code. So for here, this is all the distribution codes here. So we're gonna include these 3 library, and there's a global variable of constant integer header size 44. It meant argc and argv. Then we have to check the command lines to be eject 4. If not, we're gonna print out these statements here. Then we're gonna open the file and assign to the input. If unable to open, we're gonna print these statements, return 1, and also we're gonna open the argv2 assigns to the output. If could not open, we're gonna print these statements. Then we're gonna decline the float factors to convert the argv3, which is for our case is for example 2.0 to from strings to the floating point numbers of into the factors. Then from here, the to do is we have this uint 8t headers. Then header size is which is the 44 here. Then f reads. Then this is the address here, basically just from the inputs to the headers, and the size of 8 bits, the size of 44. Then from f write, the address, we're going to take in the size of 8 bits, header size of 44. Then to the outputs, we read from the inputs and transfer it to the outputs. And from here, the samples, we're going to modify a bit for the samples. First, we're going to use the int16t buffer, which is the 16 bits. Decline the variable of buffer, create a while loop here, the f reads. So basically the input here will go to the address here with a size of 16-bit, one at a time. Then the buffer, we're gonna update the buffer variable by times the factors. So buffer times factors is equal to buffer. So we update the samples here. Then we create the f write here. So we're gonna transfer this new sample here through the size of 16 bits one at a time to the output. So that's how we have a new output file. Then we're gonna f-close the inputs and f-close the outputs. So let's take and check whether is it okay. So you can also add return 0. So I add a return 0 as for my practice here. So it actually depends on how you're gonna code. So you can try to use the type def to change this to the bytes, which is what I mentioned just now, for more readability for the user and also other programmer to to understand your code. So after you can see here is okay, everything is good. So that's it. That is how I resolve the lab 4. So thanks for watching and see you next time.